Hello, I'm Dr. Raymer, and today we're talking about interactions between cognitive and motor development. So we divide development into these separate domains. And in one scheme, we have the affective domain, including social and emotional components. We have cognitive domain, we have a physical domain, and we have a motor domain. However, we know that all of these domains affect one another throughout development. And here, we're going to focus on this overlap, this interaction between cognitive development and motor development, and look at how they interact continuously throughout our lifetimes. We're really asking these two questions. How does our gradually emerging and changing motor ability affect cognitive development? And conversely, how does our evolving cognitive development impact motor development? Now, to have this conversation, we need to talk about the work of one of the most influential people in the field of human development, and that's Jean Piaget. So Jean Piaget was a clinical psychologist from Switzerland, and he developed the most widely accepted theory of cognitive development. His work is a bit controversial. He did a huge amount of work on his own 3 children. And he used a clinical method, a system of collecting data in question and answer sessions, and of course observing children and seeing how they solve problems. So I really feel for these poor kids. They must have been studied and scrutinized to death throughout their lives, but they certainly gave us a lot of information and a model through which to study and examine human development. So Piaget's work demonstrated that cognitive development depends crucially on the movement capabilities an individual has acquired. And of course, reciprocally, motor development depends on intellectual capacity. So that's the punchline, is they hugely interact throughout life. And the process that Piaget's model talks about is the process of interacting with the environment and adaptation. And Piaget theorized that adaptation occurs via 2 complementary practices. So assimilation and accommodation. So a lot of A words here, we'll define them. Adaptation occurs via assimilation and accommodation. So what is adaptation? Adaptation is adjusting to the demands of the environment and then thinking about that adjustment through these 2 combined acts. So this is the cycle of adaptation that we're looking at here, presented in a really simple way. When you attempt to assimilate, you encounter disequilibrium. You get thrown off balance. It's not working. And you'll see what we mean in a minute. And then you accommodate and you return to equilibrium. And that's the cycle of adaptation, according to Piaget. So assimilation occurs when children attempt to interpret or attempt a new experience based on their existing understanding of how the world works. So in this case, baby has got a ball. The ball is clearly too big to be picked up with one hand. But baby doesn't know that because just yesterday they picked up a toy with one hand and held it successfully, and a rattle with one hand. So this is an example of assimilation. You're trying to pick up something that's too big with one hand because you just did it the other day. Accommodation then is when children adjust. So this hand, baby bringing this hand into the situation, is an example, of accommodation. So in accommodation, you're adjusting your existing thought structures to account for a new experience or new information. Okay, this ball is way bigger. I'm going to have to pick it up with 2 hands. And so that's the cycle. So we assimilate when we try to do something the way we thought we could do it. It doesn't work. We get knocked off balance. We accommodate and we come back to equilibrium. And this is a motor example of adaptation, but it can work just as well with a purely cognitive example. Now, Piaget studied and classified 4 stages of cognitive development. And the rate and extent of progress through these stages varies across individuals, but the order is consistent. So each stage builds on the previous stage. And the stages are sensory motor, pre-operational, concrete operational, and formal operational. And here you can see the average ages at which these stages occur. And of course, they're average. So the sensory motor stage, you can already see it's in the name, crucially depends on motor ability. In this stage, intelligence emerges through action and consequence. So it's interacting with the environment and experiencing what happens. It's the most detailed stage that PJ described. And so there's actually 6 sub-stages to the sensory motor stage. You need to be able to name them. You don't need to be able to know them in great detail, but you need to have an idea. We'll just talk about what each of these stages really means. So the first month of life is characterized by reflexes. And so this is the reflexive stage. This baby here is exhibiting one of the most obvious reflexes, which is sucking. If you stroke the roof of a baby's mouth, it will suck instinctively or reflexively. Rooting is stroking the side of baby's mouth. They turn toward that stimulus, looking for a nipple. The Moreau reflex or the startle reflex can be really irritating for new parents. Baby startles themselves awake, flings their arms and startles themselves. The fencing reflex is weird. So if baby turns their head to one side, this same side arm goes straight and the back arm bends at the elbow. Weird little reflex. Grasping, of course, if you put your finger in the baby's palm, will grasp it. And a cute little reflex in brand new babies is stepping. So if you lift them up and put their little feet on a surface, they'll step along. And so these are fun things to do with a new baby at a time when A, you're very tired, and B, you have this new little thing that doesn't do much. It's fun to check the reflexes out. So now we get into a stage after the reflexive period. The substages are called primary and secondary circular reactions stages. This is really the onset of voluntary movement, the onset and progression out of reflexive movement into volitional movement. The circular in these stages means repeated. So a feature is repetition of movement. The primary and secondary sort of refers to how close to baby movement happens. So what sort of is the sphere around the baby of environment that it can interact with. So in the early 1 to 4 months, baby can't move anywhere and can't see necessarily very well. And so primary circular reactions happen really close to baby. Secondary circular reactions, the environment starts to spread for baby. And there's 2 key phases of this, 2 key features of this phase is what I'm trying to say. Secondary circular reactions, the phase involves a lot of repetition and near the end of the phase, imitation. Imitation, in part because the senses are developing, particularly vision, and with visual acuity comes the ability to imitate a caregiver, right? So if you smile at a baby and nearing the end of the stage, typically they smile back. So that's one of the most satisfying sort of aspects of interacting with babies in this stage. One of the most frustrating aspects of interacting with babies in this stage is their incredible enthusiasm for repetition. So if some terrible person gives your baby a toy that makes noise in this phase, you will curse that person forever because they will bang that toy or make it rattle incessantly, and they love repetition. Babies who are in the secondary circular reaction stage do not yet have object permanence. Object permanence means that if you cover a toy with a blanket, the baby will still know the toy is there. So babies before who are in secondary circular reactions, if you take something away, it's gone. They in their mind, it doesn't exist anymore. People debate when object permanence emerges, and obviously it's different for every baby. But right around the end of this stage is when some people suggest that object permanence may emerge. Now we have this secondary schemata stage, and in this stage, there's a big development in locomotion, crawling, cruising, and in some babies walking, and that movement allows baby to explore the environment and really fuels intellectual development and new experiences. And so baby develops a number of things, including the ability to plan and anticipate, and do something reciprocally, respond appropriately. So the example that's often given is if you roll a baby this age a ball, they might roll it back. And if they see you roll someone else a ball, they can anticipate that you might roll it to them and they'll get ready. And so that's a feature of this stage, and it's really enabled by crawling, cruising, and the onset of walking to allow baby to have these interactions with its environment. So tertiary circular reactions, as it's sort of getting into the second year of life. And again, tertiary in this case means further away from baby. So we have primary, secondary, tertiary. And we're really in this stage focused on experimentation for both cognitive development and motor development. So interactions with the environment, seeing what happens. Development, in addition to locomotion, development of the special senses permits more extensive interactions with the environment and a desire to understand how things work. They can see further. They want to know what's happening over there. And so that's crucial. The special sense development really crucially affects motor development in this stage. Another thing that happens in this stage is the involvement of other people to solve problems. And so I don't know if I can write, but I do want to write that down. Can't write and talk at the same time. Walk and chew gum. Involving other people to solve problems. They see people as a source of a solution. I am hungry. You are the person that gets my food. They will tug on your leg, right? And so that's, even if they don't have language yet, they have realized they can use other people to get what they need. Sounds a little Machiavellian, but it's a way to solve a problem for a baby. So in this final stage of PJ's first substage is the second half of the second year. It's classified as inventions of new means. And in this stage, baby really changes from just sort of a movement interaction with the environment to also thinking about those movements. A couple of key cognitive leaps happen in this stage. One is baby sees objects as separate from self, and they see themselves as just another object in the room. So I'm here, the computer's there, the phone is there, the apple's there. They use movement to identify properties of objects. And so they begin to interact with objects. They're doing this all through movement to drive the cognitive leap that objects have properties. They have color, they have weight, they have size, they have texture, and so on. And so using movement to drive that exploration fuels the completion through this stage. Now, a really interesting question is how cultural influences impact development in this early sensory motor phase. So one thing that's interesting and probably important is there's cultural differences in how babies are carried through this phase of life. And in some cultures, babies are carried almost all the time to promote bonding with mom and to keep baby close and safe and keep mom's hands free. So they're carried in different ways. People's huge cultural variability in how people carry babies. But what does carrying versus not carrying do to cognitive and motor development through the sensory motor phase? It's an interesting question. And presumably there would be less exploration of the environment, but more bonding with a caregiver. So that's an interesting trade-off to think about. The other thing that's interesting to consider is gendered toys. So gendered toys, I'll write that down because it's hard to write and talk. Gendered toys like the one seen here, this is a stocking ring by Fisher-Price that was marketed as a boy's toy with the primary colors, and this equivalent was marketed as a girl's toy, which is mostly pink and purple. And I look at these two and I think about a baby in this phase who's exploring with their environment, playing with a toy, learning about the properties like size and color of different objects. And then how would that experience be changed if they played with this toy, where all the rings are different colors, versus this toy where all the rings are essentially pink. And wouldn't you learn better from this one? And so that is a really interesting question. Gendered toys, to digress for a moment, are an example of market segmentation. So market segmentation means you want to niche down. It's a principle of marketing to target as specific a market, as specific a consumer as you can. So market segmentation is a key element of marketing. And that means gendered toys are they're gendered for marketing. They're not gendered for children's enjoyment or children's development. It's just selling toys. In this example, even the Kinder Surprise egg has a girl's egg and a boy's egg with gendered toys inside. So think about what it does to kids in these early phases of development and exploration if their exploration is confined to one kind of toy or another, and how that could shape their development. So in the pre-operational stage, a child's ability to move through the environment more efficiently and more effectively and further drives exploration, and that drives both cognitive and motor development. Kids in the early pre-operational stage, like these kids shown playing here, display a number of key characteristics. First, they're egocentric. They think the world is entirely revolving around them. And if you've ever been around a 2 or a 3-year-old, you are confident that they are egocentric. Their demands come first. They don't really think about the feelings of others very well all the time. And they believe that everybody sees the world exactly as they do. And you may know some adults that are egocentric, but most babies develop beyond this stage. Symbolism. They know the word dad means a person. Animism. They attribute human attributes to things. They think their teddy bear feels hurt. And a lack of understanding of what's called conservation. And we'll explain that just in a few minutes. Now, a key element of this phase is the acquisition and elaboration of language. So that's a huge thing that's going on cognitively in this stage. What's very interesting, though, is that language development is closely tied to the onset of walking. So when children begin to walk unassisted, their language skills go straight up, and they enter this really rapid period of language development. Now, this was sort of first really conclusively shown in a longitudinal study published in 2013. And longitudinal means that they took a whole bunch of babies and they followed them over time. So they followed them before the onset of walking through past when they walked. And that means it was a really intensive study because then you have to take 40-some babies and follow them developmentally for months to capture this period of interest. So here, this is sort of number of words is on the y-axis in both graphs. And you can see the different stages represented on the x-axis. And these, I should say, are marginal means. So they're statistically generated averages. So that's why there's no error bars on the graph, which may be annoying to some of you if you're nerdy like I am. But the overall trend is very clear. You can see what happens. Here's walking onset, and that triggers or is associated with, should not say triggers, a huge period of rapid development in both receptive vocabulary, number of words the baby understands, and productive vocabulary, number of words that baby can produce. Now, since that 2013 study, there's been lots of supporting evidence to demonstrate the relationship between onset of walking and language acquisition. And there's even other motor skills that are associated with bursts in language development, including sitting and crawling. It happens across cultures and across languages. So the question is, why? Well, there's a number of theories. Walking lets a child explore the environment more. That's one. It may also increase the frequency and diversity of social interactions that baby has. So if a kid can get to more people, then it can have more interactions. Other mechanisms have also been proposed. So walking represents an increase in physical activity, and exercise actually changes the brain function and structure. So it could be an exercise-induced effect. So really interesting theories. The relationship is clear, but we don't understand the mechanism fully. And probably it's a combination of these things. PJ's third stage is concrete operational. So in this stage, we're talking about kids about 7 to 11 years old. And during this stage, there's several key cognitive milestones that are achieved. The first is conservation, which we already mentioned. This is the idea, the understanding that something stays the same in quantity, even though its appearance changes. And so here's some examples of tests of conservation. So we have 2 glasses of liquid. We see that they're the same. If we pour one glass into a taller glass, and you ask a child before this stage, which has more water, they will say this one, because they don't understand conservation yet. Another test is if you have 2 equal balls of clay and you make a long, thin sausage out of one, so it's longer, a child without conservation understanding will say that this is bigger than this, and so on. So that's a cognitive leap, an understanding conservation. And during this stage, there's several other key cognitive milestones. Seriation is arranging things by a characteristic and making inferences about that. So if you arrange people by height and the center on the basketball team is taller than the forward and the forward is taller than the defenseman, a child with seriation would be able to infer that the center is also taller than the defenseman. And reversibility. Almost literally, actions can be reversed and you can make inferences based on that. So all of these are best learned or achieved through action. In the formal operational stage, this is really a cognitive leap that kids make. And a number of key aspects of cognitive development emerge. So hypothetical thinking. What if the sun never rose again? Abstract thinking. Thinking about concepts that aren't tied to direct experience, like justice and love and morality. Systematic problem solving. So if you're doing an experiment in school in a lab, you can change one variable at a time if something's not working. Metacognition. Reflecting on one's own thought process. Thinking, oh, I studied really hard for that exam, but I didn't do well. I wonder what I did wrong. Maybe if I do this. That's metacognition. Moral reasoning. Moving beyond black and white view of right and wrong. It's wrong to steal, but that person was really hungry and they stole a loaf of bread. So all of this executive function and cognitive performance is associated with motor skills, motor development, and physical activity in young people. And there's now a huge body of evidence to support this. Piaget's theory, though it fueled a whole field, really, has some criticisms about it. So a lot of his work was conducted with his own children. He may have underestimated what children were actually capable of when he created those stages. And he placed too little emphasis on the influence of motivation and emotions. So those are 3 of the big criticisms of his theory. He also kind of stopped at childhood, right? So he didn't take a lifespan approach to talking about development. He stopped with children. And some people, to continue the theory, continue the model, have named a stage that continues into adulthood called post-formal operations. So this phase, which some people call a phase, just acknowledges the fact that development is a lifelong process. And cognitive skills in most people are refined through experience and reflection. We become more realistic, we become better planners, we become better predictors with increases in experience. Now, while both motor and cognitive function can decline later in life, decline is not universal or inevitably linked to age. There's a huge array of factors that dictate the extent of cognitive decline in healthy aging adults. So I'm not talking about dementia or other diseases. I'm talking about the normal decline that occurs with normal aging. And so if we take a contextual perspective on something, in this case on age-related decline, it just means appreciating that there's many factors beyond age itself that determine cognitive performance. Motivation is one. social activities and relationships. Loneliness is terrible for cognitive function, and it's kind of an epidemic among the aging population. Cognitive practice, hugely important to maintain cognitive skills. And finally, attitude about your own cognitive abilities and potential. Those are all crucial determinants of how well you age. Now, there are really well demonstrated relationships between motor skills and physical activity and cognitive performance. And these relationships exist throughout life. So in children, motor skill development and school performance, sport performance and cognitive ability, and movement expertise and perceptual cognitive ability have all been demonstrated in children and young adults. In older adults, physical activity in many settings, I'm just crossing out that "and" because it shouldn't be there, improved cognitive function and delayed or diminished cognitive decline. So to the point where physical activity is now being considered and used even as a treatment or intervention for conditions like dementia. Now, many of the relationships we talk about in the book have been demonstrated using meta-analyses. So what is a meta-analysis? A meta-analysis is a study that uses statistical methods to evaluate and synthesize results from multiple studies on a particular topic. And so this meta-analysis, analyses are described in this schematic as filtered information. And that's the opposite of sort of an expert opinion. So when you think about the quality of evidence on a topic, this pyramid is going up. If we did an expert opinion, there's a ton of expert opinions out there. Just look at any corner of the internet, right? But there's a reason they're at the bottom of this pyramid, because they're completely unfiltered. Even a single randomized controlled trial, which is a heck of a lot better than an expert, or a non-expert for that matter, opinion, is not filtered to the level that a systematic review and a meta-analysis is. And the key characteristic of these studies is that they themselves are an aggregate of all of the available published evidence on a topic. So that's the power of the meta-analysis. Now, we know that there's a ton of evidence and meta-analyses linking physical activity and motor development to cognitive development. So what are the mechanisms? How does this happen? Well, activity and motor development measurably changes the brain and behavior, and it does it at all levels. So it makes molecular changes in the brain that we can measure. It actually changes brain structure and function, and it changes behavior. And all of these are going to impact cognitive function. So at every level, from the cellular and molecular to the behavior, cognitive function is affected by activity. Now, we don't know exactly how physical activity impacts cognitive function. We don't know why we get these dramatic improvements in cognitive function and even delay of diminishing cognitive function in aging with physical activity. What we do know is that movement is good for brain function and vice versa. And so this is a meta-analysis we just spoke about of the benefits of exercise for cognitive function in older adults. And this is the statement the conclusion they came to by summarizing all the data in the field. This was published in 2023. To improve cognitive ability, this meta-analysis recommended that patients perform at least moderate intensity aerobic exercise and resistance exercise on as many days as possible in the week to comply with current exercise guidelines. So, more movement is better, and I want you to just plant a seed. Think about what it does when someone thinks, I'm too old to lift weights, or I'm too old to ride my bike, or I'm too old to go to the gym. What are the impacts, not just for their physical condition, but for their cognitive development and potential decline?